improved wheel optimization algorithm for cluster analysis. In this presentation, I'm going to cover different contents. First one is introduction, then objectives, then next one is wheel optimization algorithms, its improvements, its pseudocode, then the result and discussion, and the last one is conclusion and future enhancements and the references. First is introduction. Now this time I'm going to work in the clustering field. Clustering is a powerful technique that groups the data into different subsets using a distance functions. Now, among from these clustering techniques, I'm going to work in the partitional clustering that decompose the dataset into several disjoint clusters that are optimal in terms of some predefined criteria. The predefined criteria is either the intercluster distance or the intracluster distance. Clustering has proved its potential in various fields such as in business intelligence, web search engines, bioinformatics, and the pattern recognition, and the many more. The objective function in this work, I have used the equilibrium distance objective function, which is used in order to optimize the different types of clusters data objects that are optimal in terms of their distance. This is a mathematical function which is used in order to find out the distance among the data objects. Objective of my work is first one, I'm going to implement the improved version of the wheel optimization algorithm for the cluster analysis. Second one, I'm going to enhance the searchability of the traditional wheel optimization algorithms. And another one, I'm also going to handle the local optimus, which is kind of problem that is going to occur in maximum algorithm when the algorithm is going to stop and it is not going to be find out any candidate solutions. Whale optimization algorithm. Mainly the whale optimization algorithm is based on the behavior of the humpback whales. Originally, that stimulates, or when they are going to find out their prey, they are using some kind of techniques, and these techniques are the mathematically formulated and represented in terms of the mathematical formulas. Like if we are able to see in the equation two, this is going to find out the distance. Another one is going to find out the best positions and the different types of their the vector that they are using. So these are the equations that are generally used in order to the different perspectives when they are either in the whale is in humble whales are in the movements, or they are going to be shrink, or they are going to be making a spiral motions, or they are going to be find out a bubble neck. There are different types of problems that are I have find out in my research gap that there is a different like there is mainly there is a random function that is used in the mathematical formulation. Now in this work I have integrated the chaotic maps, as the chaotic maps are more superior than, or it can be is going to be substitute the random functions because they are generally going to find out in a particular range. Rather than the random functions, they are used mostly used in order to find out the optimal solutions. In this work, I have integrated the QWERTY maps in this one. Second one, I am going to integrate the step division based method. This method is particularly used in order to handle the local optimal solution. Means when the algorithm is going to be stuck in any kind of position and is not going to be generate any a new candidate solutions, because we are going to find out optimal solution. But when we have the algorithm is going to stuck, we required a method. Now in this one, I have used the step division based methods. Now in this case, what we are going to find, we are going to find out the near like n number of neighborhood positions, and the neighborhood positions, they are randomly picked, and out of them these neighborhood positions, we are going to find out some kind of nominating 2 or 3 positions, and we are going to take a particular mean of these, and then we are going to identify another one solution, and that can be a new candidate solution for that. This is the pseudocode of the wheel optimization algorithm. If we are going to see, then first one, we have to upload the data set, and we have to initialize these fundamental parameters. Like we have to, in case of clustering, we have to first of all, we have to initially we have to define the number of parameters, or the random parameters is number of iterations. There are different type of variable that we are generally going to use in case of our algorithms. Then after the After initial of the initial parameters, and we are going to select a population. Like if we have selected the number of clusters, if we can say like if I have selected the number of clusters is three, then the three number of population that are in the random fashion can be picked up from the data sets. And after picking up these populations of these random samples from the data set, now we have to calculate the objective function. For taking the random sample, our next task is to calculate the objective function. Now, in order to calculate the objective function, we are using the equality distance. If after the calculating the objective function, our next task is to find the fitness. Means either the value that we have calculated is superior than the previous one, or is we are going to be in the worst condition. Now, in case the next one that we are going to find out the new vector solution, means we are going to search for the new vector position. Now, in this algorithm, we are going to work on the basis on the random variable. Now, as we have already discussed, we are going to improve this with the QWERTY maps. Now this time we are going to use the random function in place of these QWERTY maps in place of these random functions. And according to these values of this, like is from 0 to 1, we are going to switch the different conditions or the different values of the mathematical equations in this work. The next one is that is after calculating the objective function and going to settle down in the particular clusters. On our next task is to find the local optimal solution. Means if we are getting a after iterations, if we are getting the same values, means the algorithm is stuck in the local optimization. In that case, we have to use this step division based method, a neighborhood strategy that can be used to overcome this local solution. Means with the help of this, we are going to identify a new position, that is the we are going to find out the best at least 10 neighboring positions, and then we are going to calculate their particular means, and then we are going to identify a new vector position. In this work, I have implemented this particular improved version of the wheel optimization algorithms. And now this time I have tested this algorithm on the different real-time data sets that are downloaded from the UCI repository. And I have compared with the different existing algorithm. Now in this work, if you are able to see the improved wheel optimization algorithm, it is compared with the wheel optimization algorithms, and it is getting the better result. Now in this time, if we in case of iris, if we are able to see, we are getting the 95.80, as compared in the wheel optimization we are getting the 96.79. Means the intercluster distance in case of improved is better than the wheel optimization algorithm. Next one, the performance parameter that I have taken is the F measures. Means in case of F measure, means how accurately is going to identify, or is how accurately is the data objects are going to be identified in a particular class. That is it is how it can be accurate. So in that case, I have calculated the F measure value. The last one, that is conclusion and the future enhancement. Now in this work, we have I have proposed the improved wheel optimization algorithm. In this, I have incorporated two additional operations. First one is to handle to improve its strategies. Another one is with the help of QWERTY maps. Another one is I have used the neighborhood strategy that is used in order to handle the local optimal situations. And its efficacy and its efficiency is of this algorithm is tested on the different data sets that are downloaded from the UCI repositories, and as well it is compared with the six existing clustering techniques. From the simulation results, we are able to validate that this particular algorithm is going to be better than the previous one algorithms. And another one is that is the in future endeavors, we are going to implement this algorithm in the vehicular networks. And this in vehicular network, we are primarily going to identify or focusing on the cluster head formation and the load balancing. These are the references that I have cited in this article. Thanks.